what we're looking at here is the permutation formula. And the formula looks like this. You see it here. The formula for permutations is NPR, so N pick R is equal to N factorial over N minus R factorial. Where N is the number of objects in the selection pool and R is the quantity of objects we wish to arrange. We've used this already, but pretty much we've just used our calculator and decided what's N, how many objects are there to choose from, and then what's R, how many are you picking. But this is the actual formula that your calculator does to figure that out. And there are times when you may want to use the formula. So the first two questions here are just asking you to evaluate 4 pick 3 and 12 pick 3 without using your calculator. If we're going to do that, 4 pick 3 is going to be equal to N factorial. N is 4, so 4 factorial over N minus R factorial, so 4 minus 3 factorial. Which is 4 factorial over 4 minus 3 is 1, so 1 factorial. And then if we just look at expanding that factorial, that's 4 times 3 times 2 times 1 over 1, and that's equal to 24. If you take out your calculator and you type in 4 pick 3, it should come out to 24. Part B, 12 pick 3. So in that case, N is 12 and R is 3, so it would be 12 factorial over 12 minus 3 factorial. 12 factorial over 12 minus 3 is 9 factorial. And we did see something like this before. I'm going to write the 12 as 12 times 11 times 10 times 9 factorial. I can stop at any point when I'm decreasing from 12 and put a factorial. And then and the reason I stopped at 9 is because then those 9 factorials cancel out, and it's just 12 times 11 times 10, which is equal to 1,320. 12 times 11 is 132, and then times 10. The last question here asked you to write 5 factorial over 3 factorial as a permutation. Well, we need to figure out what N and R are, and you can probably figure them out without actually like using the formula and solving for R or something. But what is N if this is what we are doing? N is 5, right? So it's going to be 5 pick something. And what is it that you're picking? 2, because 5 minus 2 is 3. And that's what we want on the bottom, N minus R. So 5 minus R must be 2 to get 3. These type of questions are a little bit different. It's solving equations, but using what we know about factorial and permutations to do it. And I'm not going to do all 4 of these, but let's look at A. Basically, we have to figure out what N is equal to, and it says N factorial over N minus 2 factorial equals 5N. To do that, we need to expand, well, at least one of the factorials. I'm going to expand the numerator there, N factorial, and what can I change N factorial into? N times N minus 1 times n minus 2 factorial, and I stop at n minus 2 because there's an n minus 2 factorial on the bottom that I want to cancel out. We end up with this equation n times n minus 1 equals 5n, which is a quadratic that you should be able to solve. I'm going to expand this to n squared minus n equals 5n. And then if I move the 5n over, I get n squared minus 6n equals 0. And I can solve that by factoring. Just remove a common factor of n minus 6, which tells me that n equals 0 and n equals 6. But I'm wondering if both of those answers are valid. Anytime that you do kind of some canceling with a numerator and a denominator to simplify something like that to solve, you may end up with extraneous solutions. And I feel like one of these might be extraneous. What do you think? N cannot actually equal 0 because that denominator is undefined when n equals 0. Let's also have a look at C, just because when I look at it off the top of my head, I'm not sure what to do with it. So we might as well try it. This is Cn factorial over 10 equals n minus 1, pick n minus 3. I feel like I'm not going to have enough space here, but we'll work at that. So when you look at that, I want to expand that permutation. So look at the permutation formula, and in this case, where I have n minus 1, pick n minus 3, what is n in the formula? N minus 1. So I'm going to go n minus 1 factorial over, and then again n minus 1, but what's r? Minus n minus 3 factorial. I somehow need to simplify that. So the only thing I did in this step was simplify this n minus 1 minus n minus 3. The n's are gone because it's n minus n, and then it's negative 1 plus 3, because those two negatives together make a positive, which is 2, and then it's factorial, but 2 factorial is actually just equal to 2. So I don't even really need the factorial part there. I think I want to expand that n factorial and make it an n times n minus 1 factorial over 10 equals n minus 1 factorial over 2. And then what? Can I cancel something? The n minus 1 factorial, right? There's one on each side. So really, technically what I would be doing is dividing both sides by n minus 1 factorial, and they both cancel out. So we end up with n over 10 equals 1/2. So multiply by 10 and we end up with n equals 5.